Hi there, welcome to edupediaworld.com. You are watching the videos on polynomials. So in this video we'll discuss algebraic identities. So the first identity we'll be discussing is x cube plus y cube equals to x plus y into x square minus xy plus y square. The second identity we'll be discussing is x cube minus y cube equals to x minus y into x square plus xy plus y square. The third identity we'll be discussing is x cube plus y cube plus z cube minus 3xyz equals to x plus y plus z into x square plus y square plus z square minus xy minus yz minus zx. Then again we will be discussing some of the advanced questions and concepts. So again we'll follow the same procedure. We'll solve each and every identity with examples. So you listen carefully. So let's get started with the first identity. Okay, the first identity we will be discussing is x cube plus y cube equals to x plus y into x square minus xy plus y square. So we'll solve this identity first. So watch and listen carefully. So our identity is x cube plus y cube equals to x plus y into x square minus xy plus y square. So again, how you can solve this identity is by bracket multiplication. So what we do is we'll do bracket multiplication. So we can write x into x square minus xy plus y square plus y into x square minus xy plus y square. So what we'll get is x into x square is x cube, x into minus xy is minus x square y, then x into y square is plus x y square, then plus y into x square is plus x square y, then plus y into minus xy is minus x y square, then plus y into plus y square is plus y cube. So what we'll get is, after rearranging, is x cube plus y cube. Now see, this term minus x square y and this term plus x square y, these are both like terms and they are also equal, but they have opposite signs, so they will get cancelled. Similarly, this term xy square and minus xy square, these are both like terms and both are equal, but again they have opposite sign, so they will also get cancelled. So we are left with x cube plus y cube. So this is the solution of the identity. Similarly, we'll solve the next identity. The identity is x cube minus y cube equals to x minus y into x square plus xy plus y square. So again, how you can solve this identity is by bracket multiplication. So we'll write like this: x into x square plus xy plus y square and minus y into x square plus xy plus y square. So we can do like this is x into x square is x cube plus x into xy is x square y, x into y square is plus x y square, then minus y into x square is minus y x square, then minus y into plus xy is minus x y square, then minus y into plus y square is minus y cube. So this can be written as x cube minus y cube. Then similarly this term x square y and minus yx square, these are both like terms and equal, but they have opposite sign, so they will get cancelled. Similarly this term and this term, they have equal signs, both are equal terms, so they will also get cancelled. So we are left with x cube minus y cube. So this is the solution of the identity. Now further we'll solve examples related to these identities. So these type of examples generally come in the examination, so watch these examples carefully. Now the first example is we have to factorize each of the following, like first and this, using identities or whatever means, but we will try to use the identities. So the first question is 27 y cube plus 125 z cube. So how you can do is, you have direct implication that we have two terms and both the terms have power cube. So which directly implies that we can apply identity x cube plus y cube equals to x plus y into x square minus xy plus y square. So we can write 27 y cube plus 125 z cube. Now how to solve this now? See, we have 27 y cube. This can be written as 3 y cube. How? See, we have y cube which will come out to be y cube, so this justifies this, but 27 can be written like this, 3 into 3 into 3, which makes 27, so this can be written as 3 cube, so we can make 3y whole cube as 27 y cube. Similarly we can write 125 z cube as 5 z cube. Now what we have to do further is we have to match these terms with the terms of the identity. So this, which directly implies that we have x as 3y and y as 5z. So this implies is 3y whole cube plus 5z whole cube can be written as 3y plus 5z into 3y whole square minus 3y into 5z plus 5z whole square. So which is equals to 3y plus 5z into 3y whole square is 9y square minus 3y into 5z is minus 15yz plus 5z square is 25z square. So which factorize the equation. So this is how we factorize using the identity. So similarly we'll do the next question. So the next question is, we have to factorize 64 m cube minus 343 n cube either by identities or by any other means. So we will try to use the identities. So in this question also we have two terms and both the terms have power cube. So which directly implies that we can use the identity x cube minus y cube, which is equals to x minus y into x square plus xy plus y square. Now similarly we can write 64 m cube minus 343 n cube as 4 m cube whole cube minus 7 n whole cube. How? Because we can see that 64 can be written as 4 into 4 into 4, and 343 can be written as 7 into 7 into 7. So which makes the whole cube. Then we can match these terms with the terms of the identities. What we get is x as 4m and y as 7n. So this implies is 4m whole cube minus 7n whole cube can be written as 4m minus 7n into 4m whole square plus 4m into 7n plus 7n whole square. So this can be written as 4m minus 7n into, now 4m whole square is 16 m square, and 4m into 7n is plus 28 mn plus 7n whole square as 49 n square. So this is how we factorize the identity 64 m cube minus 343 n cube using identities. Now next we will see the next identity. Okay. The next identity is very important identity, which is generally asked in exam in long term type of questions. So you have to watch this identity and use this identity very carefully. So first let's solve this identity, then we'll solve the special case for this identity. So watch carefully. The identity is x cube plus y cube plus z cube minus 3x yz equals to x plus y plus z into x square plus y square plus z square minus xy minus yz minus zx. Now we have to solve this identity. How you can solve is again with bracket multiplication. So how you do is we will do bracket multiplication. So bracket multiply x into x square plus y square plus z square minus xy minus yz minus zx plus y into x square plus y square plus z square minus xy minus yz minus zx, then plus z into x square plus y square plus z square minus xy minus yz minus zx. Now we'll open the brackets. So x into x square is x cube plus x into y square is x y square, x into z square is plus x z square, x into minus xy is minus x square y, x into minus xyz is minus xyz, x into zx is minus zx square plus y into x square is x square y plus y cube, then y into z square is plus y z square, then again it will come minus x y square minus y square z minus x y z, then plus z x square plus z y square plus z cube minus x y z minus y z square minus z square y. Now what we'll do is we'll cancel the like terms and the terms which are equal. Now see, this term and this term are equal, so they will get cancelled since they have opposite sign. Now this term x square y and this term these two terms are equal and have opposite signs, so they will also get cancelled. Then this term and this term, these are equal and have opposite signs, so they will also get cancelled. Again this term and which one is this term, they are equal and have opposite sign, so they will get cancelled. Similarly we have this term and this term equal and opposite sign, so they will get cancelled, and this term and this term, they will also get cancelled. So what we are left with? We are left with x cube plus y cube plus z cube, and we have 3 minus terms of x, y, z. See, one term and one term, they have all equal sign, so they will get added, so it will come out to be minus 3x, y, z. So which is the proof of the identity. Now we have special case for this identity. The case is if x plus y plus z equals to 0, then we have x cube plus y cube plus z cube equals to 3x, y, z. How? See, we have identity x cube plus y cube plus z cube minus 3xyz equals to x plus y plus z into this term, into this whole term. When we put x plus y plus z equals to 0, see, we have x cube plus y cube plus z cube minus 3xyz equals to x plus y plus z into x square plus y square plus z square minus xy minus yz minus zx. Now when we put this term as 0, this whole term as 0, so then what will happen is 0 multiplied with any term will become 0. So this implies is this will come out to be x cube plus y cube plus z cube minus 3xyz equals to 0. So the term will become this. So this is a special note for this identity, which is very helpful in exam to solve these some type of questions. So the questions that we will discuss also. So now let's see the example related to this identity. So we have to factorize 8x cube plus y cube plus 27z cube minus 18xyz. Now in this question we have 3 cube terms, so which directly implies that we can apply the identity x cube plus y cube plus z cube minus 3xyz equals to x plus y plus z into x square plus y square plus z square minus xy minus yz minus zx. So how to apply? See, we have question 8x cube plus y cube plus 27z cube minus 18xyz. So we can write 8x cube as 2x whole cube and y cube as y whole cube plus 3z as 27z cube as 3z whole cube. Then how you can write this? We have now for this term you have to match this term with this term. We have 3 over here, so we take 3 as common, then multiply with 2x, then multiply with y, then multiply with 3z. Then we check whether the multiplication of this term comes out to be this term. So the answer is 3 into 3 is 9, 9 into 2 is 18. So answer comes out to be 18xyz. So which verifies that we can apply the identity. So this will become 2x plus y plus 3z into 2x whole square plus y square plus 3z whole square minus 2x into y minus y into 3z minus 3z into 2x. So the answer comes out to be 2x plus y plus 3z into 2x whole square is 4x square plus y square, then plus 9 z square minus 2xy minus 3yz minus 6xz. So which is the factorization of the question using identity. Now next further we'll discuss some of the advanced questions and concepts which are very important, and these type of questions generally come in the examination, so you have to watch this question carefully. Now suppose it's given if x plus y plus z equals to 0, then show that x cube plus y cube plus z cube equals to 3xyz. As already discussed in the identity, we have 3 terms and each term has power cube. So which directly implies that we can use the identity x cube plus y cube plus z cube minus 3xyz equals to x plus y plus z into x square plus y square plus z square minus xy minus yz minus zx. So what we are given is we are given x plus y plus z equals to 0. So what we can do is we can put the value of this x plus yz over here. So we will see what we get is x cube plus y cube plus z cube minus 3xyz equals to 0, because x plus y plus z equals to 0. So we put 0 into x square plus y square plus z square minus xy minus yz minus zx. So in this term 0 multiply with anything will become 0. So this implies is x cube plus y cube plus z cube minus 3xyz equals to 0. So this implies is x cube plus y cube plus z cube equals to 3xyz. So which proves the question. So let's move on to the next question. The next question is without actually calculating the cubes, you have to find the value of each of the following question. So let's see how you can solve this. First question, you have minus 12 whole cube plus 7 cube plus 5 cube. Now again, the best way we can do is we can apply any identity we have discussed so far. So what we can see is we have 3 terms and we have cube powers. So which directly implies that we can apply the identity x cube plus y cube plus z cube minus 3xyz equals to x plus y plus z into x square plus y square plus z square minus xy minus yz minus zx. Now, so further what we have to check is if x plus y plus z comes out to be 0. So for the first question we have x as minus 12, y as 7 and z as 5. So when we add these terms, like this, we can say minus 12 plus 7 plus 5. So it will come out to be 0. How? It will become minus 12 plus 7 is minus 5 plus 5. So this term will cancel. So the answer is 0. So this implies that the addition of these terms, these three terms, gives you 0. So we can apply the special note we have discussed for this identity, that if x plus y plus z equals to 0, then this implies is x cube plus y cube plus z cube equals to 3xyz. So this implies is minus 12 whole cube plus 7 whole cube plus 5 whole cube can be written as 3 into minus 12 into 7 into 5. So the answer will come out to be 12 into 3 is 36, into 7 into 5 is 35. The sign is minus. So 36 into 35 is 5 6 are 30. Then 18, then 0, then 6 3 are 18, then 1 3 3 is 9, then 10. So the answer will come out to be 0. 8 plus 8 is we can write over here, sorry, 0. 8 plus 8 is 16, 1 carry 2 1. So the answer is minus 1 2 6 0. So this is how we can solve these type of question without actually calculating the cube using identities. So similarly, we'll discuss the second question. The second question is 28 whole cube plus minus 15 cube plus minus 13 whole cube. So again we can check is 28 plus minus 15 plus minus 13 comes out to be 0. How? 28 minus 15 will be 13, plus minus 13 is minus 13, which will be 0. So this implies is we can again apply this special note over in this question. So this implies is 28 whole cube plus minus 15 whole cube plus minus 13 whole cube can be written as 3 into 28 into minus 15 into minus 13. So then further we have to multiply these terms. So what we can do is we can multiply. It will be 28 into 15 into 13. So when you multiply these terms, 3 into 28 into minus 15 into minus 13, so the answer will come out to be 16380, and the sign will be plus. Why? The minus minus will become plus. So again I repeat, when you multiply these three terms and 28 into 15 into 13 with 3, the answer will come out to be 16380. So these are the some of the advanced question related to polynomial identities. So thank you once again for watching the video on polynomials on edupediaworld.com. So keep watching further videos on polynomials. So have a nice day ahead.